activity. Make two identical pipes made from cardboards of sufficient length. Arrange them on a table near a wall. Keep a clock near an open end of one of the pipes and try to hear the sound of clock through the other pipe. Adjust the angle between the two pipes in such a way that you can clearly hear the sounds from the clock. Draw lines along the pipes. Also, draw the normal to the wall at the point of meeting of the two lines. Now measure the angle of incidence and reflection. It is found that the angle of incidence is equal to the angle of reflection. What happens if the pipe on the right is lifted vertically to some height? We cannot hear the sound of the clock. The reason is the reflected sound travels in the plane containing the incident sound wave and the normal drawn to the wall. The angle of incidence of sound is equal to angle of reflection of sound. The normal to the reflecting surface at the point of incidence, direction of incident sound, and reflected sound lie in the same plane.
Echo.
If you visit a picnic spot in the mountains, you will generally come across a point called the echo point. When we shout near the echo point, we will hear the same sound again a little later. This sound is called an echo. This is an example of reflection of sound from reflecting surface at a certain distance from the listener. Echo is repetitions of sound due to reflection of original sound from any surface. The sensation of sound persists in our brain for about 0.1 second. That is, our brain cannot distinguish between two sounds if they reach our ear with an interval between them is lesser than 0.1 second. When we shout before the echo point, we hear the sound first. The sound travels towards the obstacle and reflects back to reach our ears after 0.1 second, and we hear our shout once again. This is the echo of our shout. The speed of sound at 22 degrees Celsius is 344 meters per second in air. Hence, the minimum distance the sound should have traveled in 0.1 second is given by distance is equal to speed into time is equal to 344 meter per second into 0.1 second. Therefore, distance is equal to 34.4 meter. This is the distance the sound has travelled from the source, you shouting, to obstacle and back to the observer, you listening. Therefore, for hearing distinct echoes, the minimum distance between the source of sound and obstacle must be 17.2 meter at 22 degrees Celsius. The minimum distance for echo will be different for different temperatures. Due to successive or multiple reflection, echoes may be heard number of times. Example: Gol Gumbaz, a dome in Bijapur, Karnataka. Here you can hear almost 7 echoes of your voice. The rolling of thunder is due to the successive reflections of sound from the clouds and from the land. Reflection of sound is utilized in measuring the depth of oceans. Sometimes reflections of sound may be undesirable. Which ones are they? These are the unwanted reflections of sounds in an auditorium. An auditorium is designed in such a way that there will be no echo produced harming the sound quality.
Now, let us solve numerical examples based on the concept of echo. 1.
A child shouted hello near a cliff and heard the echo after some time. If the speed of sound is taken as 345 meter per second at a certain temperature and the distance between cliff and the child is 690 meter, calculate the time after which the echo is heard by the child. Solution. Data given. Speed of sound is equal to V is equal to 345 meter per second. Distance of cliff from the child is equal to D is equal to 690 meter. Total distance the sound will travel is equal to distance from child to cliff plus distance from cliff to child is equal to 2D is equal to 1380 meter. Time after which echo is heard by the child is equal to T is equal to what? As speed is equal to distance upon time, therefore time is equal to distance upon speed. T is equal to 1380 upon 345 equal to 4 seconds. Time after which echo is heard by the child is equal to 4 seconds.
Reverberation.
To understand what is reverberation, let us do some activity. Close all doors and windows of the room. Play radio or music system with maximum possible volume. What do you feel? The sound of the music you are listening seems like jumbled and prolonged. A sound created in a big hall gets reflected from the walls and roof and repeatedly reach our ear. The intensity of the reflected sound gradually decreases. The sound reflected by obstacles at different distances reach us at different intervals. This happens till the intensity of the sound gradually decreases and becomes very low to be heard. Therefore, the sound heard seems to be continuous or prolonged. This persistence of sound due to repeated reflection is called reverberation. Some public halls or auditoriums are considered acoustically poor if effects of reverberation are not taken care of. To reduce reverberation, the roof and walls of the auditorium are covered with sound-absorbent materials like compressed fiberboard, rough plaster, or draperies or curtains. The material for the seat is selected such that it is good absorber of sound waves.
Uses of multiple reflection of sound. Some of the applications of reflection of sound are used in the working of devices such as stethoscope, bulb horn, megaphone and soundboard. Stethoscope. This device is used by doctors to examine the patients. It works on the principle of multiple reflections of sound. The stethoscope has two earpieces and a chest piece. The doctor puts the earpieces into his ears and the chest piece on part of the patient's body to examine heart and lungs. The multiple reflections of sound waves of the heartbeats or lungs reach the doctor's ears through the stethoscope, allowing him to judge the functioning of the organs. Megaphone. Megaphone or the speaking tube is a cone-shaped or funnel-shaped device used to amplify and direct the voice of a person who speaks into it. It is generally used in small gatherings, fairs, demonstrations, and tourist spots. The megaphone has two ends. One is a narrow end from where the person speaks, and the other wide end. When the person speaks, the sound waves produced by the voice are barred from spreading by consecutive reflections from the wider end of the megaphone tube. This causes the loud sound of the voice of the person reaching larger distances. A bulb horn also works on the similar principle of reflection of sound, just like the megaphone. Soundboard. A soundboard is a curved-shaped board that is placed at the back of the speaker in large halls, rooms, or auditoriums so that the sound reaches to people sitting at the back. In large rooms, halls, and auditoriums, the sound can be absorbed by walls, floor, roof, ceiling, and even clothes of persons sitting inside. Hence, the sound does not reach to larger audience. Using soundboard helps in solving this problem by reflecting sound evenly to all places of the hall. A soundboard works on the principle of multiple reflection of sound. The concave surface of the soundboard reflects the sound of the speaker to the audience and thus avoiding the spreading of the sound in different directions. Range of hearing in humans.
You may be surprised to know how the bats travel at nights in the dark without colliding with any obstacles. They emit sound waves of frequencies more than 20,000 hertz, which cannot be heard by human beings. They hear the reflected sound from obstacles and navigate in the dark. The sound of frequency more than 20,000 hertz is called ultrasonic sound or ultrasound. Human ear cannot hear a sound of frequency less than 20 hertz. It's called infrasonic sound or just infrasound. That is the reason you cannot hear the sound produced by the vibrations of pendulum, but you can hear the buzz produced by a bee, as the frequency of the sound wave produced is in the audible range. The audible range of sound for human beings is from 20 hertz to 20,000 hertz. Children under the age of 5 and some animals like dogs can hear up to 25,000 hertz. As people grow older, their ears become less sensitive to higher frequencies. Sound produced by vibrations of earth before earthquake is infrasound, which cannot be heard by human beings. Ultrasound. Sound waves having frequencies greater than 20,000 Hz are called ultrasonic sounds or ultrasound. The ultrasound is produced by some animals like dolphins, bats, rats. Moths of certain families can hear ultrasound produced by bats, and they can protect themselves from capture by bats. Dogs also can hear ultrasound. The ultrasound has very useful property of traveling along a well-defined path even in presence of obstacles. This makes it very useful tool for industrial applications.
Hearing aid. People with hearing loss may require a hearing aid. A hearing aid operates on a battery. The device consists of microphone which receives sound waves and converts them to electrical signals. These electrical signals are then sent to an amplifier that makes them louder. A speaker of hearing aid receives these amplified electrical signals, which converts them to sound and sends to the ear. Applications of ultrasound. Ultrasonic sound is used to detect internal cracks, flaws, and other defects. Ultrasound is used in industry to clean parts that are hard to reach, like electronic components, machines, and spiral tubes and pipes. The high-frequency ultrasound waves stir up the cleaning solution, thus loosening and detaching foreign particles from the objects. Ultrasound waves are used to investigate human organs for medical and surgical diagnosis. Ultrasound scans are also used to check the development of the fetus inside the mother's womb as well as detect any growth abnormalities. It is found to be safer than the X-rays. Ultrasound is used to break kidney stones into smaller particles to flush them out with urine. Sonar.
Sonar is an acronym for sound navigation and ranging. Sonar measures the distance, direction, and speed of underwater objects using ultrasonic waves. Sonar consists of a transmitter and a detector. It is installed in a ship or a boat. The transmitter produces and transmits ultrasonic sound waves. These waves travel through water. They get reflected back after striking the object on the seabed. The reflected waves are sensed by the detector. The detector converts the ultrasonic waves into electrical signals which are appropriately interpreted. The time interval between transmission and reception of the ultrasound is recorded. If the speed of sound in seawater is equal to v and time interval is equal to t, then the total distance travelled by ultrasound 2d is equal to speed into time. Therefore, 2d is equal to v into t. Hence, the depth of the seabed d can be determined. Uses. Sonar technique is used to measure the depth of a seabed. It is used to locate underwater hills, valleys, submarines, icebergs, and sunken ships.
Let us now solve numerical examples based on concept of echo. 1. A submarine emits a sonar pulse, which returns from an underwater cliff in 1.02 seconds. If the speed of sound in salt water is 1,531 meters per second, how far away is the cliff? Solution. Let us first write the given data. Time taken by sonar pulse to return, t, is equal to 1.02 seconds. Speed of sound in salt water, v, is equal to 1,531 meters per second. To find the distance of the cliff from submarine, d, distance travelled by the sonar pulse is equal to 2d, where d is the distance of the cliff from submarine. Distance d is given by v into t divided by 2. Substituting the given values, we get d is given by 1,531 into 1.02 divided by 2. d is equal to 780.81. Thus, the distance of the cliff from the submarine is 780.81 meters. Structure of human ear.
Human beings hear sound through one of its most important organs, the ear. It converts audible pressure variations in air into electrical signals. These signals travel to the brain via the auditory nerve. There are three major parts of the ear. 1. External ear. 2. Middle ear. 3. Inner ear. The external part is called the pinna. The pinna collects the sound and is carried by auditory canal to the eardrum. The eardrum is a thin tympanic membrane. It is set into vibrations due to the pressure variations in the sound reaching it. When a compression of a medium reaches the eardrum, the pressure moves it inward. When a rarefaction reaches it, the eardrum moves outwards. The vibrations of the eardrum are amplified and carried to the inner part of the ear. The auditory nerve connects the part of inner ear to the brain. There is a snail-like shell in the inner ear called cochlea. Cochlea is responsible for recognizing the qualities of sound, that is, loudness and pitch. In cochlea, the vibrations received by the eardrum are converted into nerve impulses or electrical signals. These signals are sent to the brain via the auditory nerve. The amplitude of vibration of membrane gives the brain a measure of loudness of sound.